Today we're going to talk about when a function is increasing and when a function is decreasing. So let's say you have a function that is increasing on some interval. If you began to draw lines tangent to that function, you might notice that all of your tangent lines have positive slopes. Now, if you drew a function that was decreasing, and then drew tangent lines to that function, you might notice that all of your tangent lines have negative slopes. We use that information to test where a function may be increasing or decreasing. Increasing function means positive slopes, decreasing function means negative slopes. So we're going to have our functions on their intervals be continuous and differentiable. And if that is true, we know that if our derivative is positive for all x in the interval, then our function must be increasing. If our derivative is negative, then our function must be decreasing. And we already knew that if our derivative is 0, then our function must be constant. So here we have a function, x cubed minus 3/2 x squared. We're going to find out where this function is increasing and where it is decreasing. So we're going to need to know where to look, and that would be at our turning points. We want to see where our function changes direction, which would be at our critical numbers. So we first find our derivative. We set our derivative equal to 0. We get x equals 0 and 1. And our derivative is never, make that a little neater, is never undefined because our derivative is a polynomial, which means that our critical numbers are just x equals 0 and 1. Our next step is to make a table. And what I'm going to do is I'm going to take the factors of our derivative. I've got 3x and x minus 1. And I'm going to write the factors like that. And there are different ways of writing this. You may want to, instead of writing 3 and then x separately, you can put the 3x together. But I'm going to leave mine the way I have them. And then if we multiply them all together, we get f prime. Then I'm going to set my intervals so that they're between the critical numbers. So the domain of our function is negative infinity to infinity, and we know we've got turning points at 0 and 1, possibly. Now we consider the sign of each of the factors on each of these intervals. So 3, no matter what the interval is, will always be positive. So I'm going to say that this is positive, positive, positive. Now x will have negative values on the first interval, but positive values on the next two. So this will be negative, positive, positive. X minus 1 will be negative here and negative here, but then positive. Negative, negative, positive. Now we know that this times this times this is equal to f prime. So we've got a positive times a negative will be a positive value for the derivative. Here, positive times a negative will give us a negative derivative. And in the last column, all the factors are positive, so our derivative must be positive. This means that our function must be increasing, then decreasing, then increasing again. Then the very last thing that we need to do is answer the question. We want to know where this function is increasing and decreasing. Well, we can say that f is increasing on negative infinity to 0, and then from 1 to infinity, because our derivative is positive on that interval. F is then decreasing between 0 and 1 because f prime is negative on that interval. And here is our summary. In order to determine where a function might be increasing or decreasing, first you need to find your critical numbers. That's where your derivative is equal to 0 or undefined. You create a sign chart using the factors of the derivative and your critical numbers. From your sign chart, you know that if your derivative is positive, that your function must be increasing, and if your derivative is negative, your function must be decreasing. And then your last step is to write out statements based on what you found on your sign chart.